Good afternoon, good evening, wherever you're coming from today. My name's Manny, and welcome to another edition of LED's webinar series.
And for the next few, 30 minutes here, we'll try to talk about the connection between lean sustainability and decarbonization. It's an interesting topic. And me and David, we started talking about this for, I don't know, maybe 3-4 months ago. And then we were finally here. And, again, thanks for the opportunity. So I think the first thing that we're going to talk about is why, what do you mean by decarbonization? In simple terms, it's really eliminating the carbon emission from the world, right? Anything that is man-made. And that picture talks of clearly. And as you can see there, the buildings accounting for about 40% of the energy use and about 38% of GHG, greenhouse gas emissions in the world. And interestingly enough, our industry, HVAC, accounts and, play a key role in reducing fossil fuel dependency. A quick relation that we can think about that is if you try to burn, if there is a 1 kilogram of refrigeration that is emitting from a system, it could be one of the old refrigerant like 410 or equivalent, that will be equivalent to about 2 ton of carbon dioxide, and that's again same as running a car ideal for about 6 months straight. So that, if you look at that math, that's huge. How much HVAC industry provide or contribute towards, carbon emissions. So we as an industry has a big play in controlling, this narrative, of sustainability. And, we are committed to make sure that we hit the right, hit metric in the right time. All right. So, honestly, there are about few different drivers of decarbonization. On the left side, you can see the ESG or environmentalism, in which there is a big talk in the finance world with S&P 500, SEC Commission. They're trying to regulate this from that perspective. But on the right side, we can see a lot of local policies that have been trying to change this narrative for us, personals on our day in day out life. There is about 339 cities that have quantifiable emission reduction target that includes natural gas bans, carbon caps, stretch goals, and carbon tax. And stretch goals are interesting because if the city cannot get the base code, if they cannot achieve their carbon emission by using the base code, they're going to implement stretch goals to see how they can capture this carbon. And depending on the city you are in, things could change either way. Some are rewarding, some are not so rewarding. There are cities such as New York, Massachusetts, British Columbia, all have stretch goals in their policy. And some slides down the line, you will see how this is even a law in Europe. And some of these are code and some are not code, but some are law, some are not law.
So the first part is, we talk about electrification in the sense of utilizing electricity in the place of gas. And it starts with our utility grid emissions, because if we're talking about utilizing electric power, it's really how clean is our electric power? And as I'm located very, very close here to kind of the center of the country, you can see that is quite different depending on the different areas of the country that you are located in. The Pacific Northwest, obviously, you can see is very clean. They have a lot of hydro. You're talking about renewables. And as you get in different areas of the country, Midwest, we're not as clean right now. And so that really affects not only what we're doing today, but also how we transition to the future. So the type of equipment, the type of chillers and heat pumps people install today affect our emissions today, but also in the future. And so those are the questions we're answering as people are making these transitions to heat pumps is, if I make a transition today, what does that mean? And am I also putting the right equipment in today to achieve those future sustainability goals? So when we look at the rise of renewables, and so this chart is showing you what people are installing today for new capacity build, you can see that compared to years ago, 2000s, the early 2000s, where there was a lot of gas generating capacity build being installed, today you can see the blue sections lining up quite a bit more, meaning that we are investing in renewables. So today the mix is much different than it was many years ago, and we are trending toward having more renewable energy. So what does that mean? What it really means is that if we were to install all heat pumps today, right? Electrification sounds pretty. It sounds like we're going to solve all of these problems right up front. And the reality is, in a lot of situations, and here we're kind of taking an average across the United States, if we were to take our current gas and electric mix and say, we are electrifying everything, guess what? Our total carbon emissions would be about equal. And that's because of where our grid sits today. But because we are investing in these renewables, and we are changing how systems are going to operate, and we're looking toward a future where there is a more sustainable grid, then you can see an all-electric grid here proposing in 2030, if we have that sort of mix between coal, natural gas, and carbon-free sort of emissions, sort of supply, what we can see is we would have the opportunity to have a huge reduction. So there's two different scenarios shown here on the slide. And in the first, we're essentially cutting the carbon emissions in half. And if we're able to even supply a higher renewable mix, we could cut that down to 25%. So there's huge opportunity to move toward electrification, even though that is not necessarily the full picture today. So when we talk about natural gas heating versus electrified heating, we have seen that trend move toward heat pumps because of the opportunity to reduce carbon emissions in the future, because a boiler system historically, has been a gas boiler in most installations, and the byproduct there is carbon dioxide. So as we move to electrified heat, we have more choices in order to reduce our emissions. And so when we talk about electrification solutions, there's so many, and we're not going to get into the details really of any of these today, but we're really going to kind of focus on what we can do when people start talking about a traditional heat pump system. So there's a lot of different things at the system level that then transition down to actual products that you buy. And I think when we talk about heat pumps, we're usually most familiar with, and I think you focused last session on residential heat pumps, and that's probably the easiest to visualize. And in fact, I even upgraded recently the heat pump at my home. I used to have an external air conditioning unit that sat outside, and I had a more traditional furnace, gas furnace inside of my house. When I needed to have that replaced, I actually replaced my external unit with a reversing valve air-cooled heat pump. And the reason that I did that is, number one, I'm in the industry, right? But I have the opportunity there to move toward electrification. And what I'm kind of example showing on the screen here is water-to-water heat pump. And you could have either an air-to-water or a water-to-water, as we just said, or air-to-water, on your residential side. And the same thing can be said for the commercial side. And the reason I say that is commercial, we're usually talking about larger units. So we have a larger impact. And so there's a lot of different ways we can achieve that. And the reason that we really want to focus on commercial also is because we have an opportunity for heat recovery. So when I talk about overall a heat pump, that definition is basically just saying it could essentially use a chiller heater. There's a lot of terminology in our industry, but overall, I'm going to say it's anything that's moving heat, which today really is a chiller. And that's why I'm here talking about heat pumps. So in a lot of large installations, you have a lot of cooling load handled by a water-cooled chiller in this diagram. And what happens is we provide on the evaporator side chilled water for whatever load, typically, your air conditioning load, but also for different processes. And what we do on the condenser side is we throw that heat away. We throw that heat away. So what we're doing is we have on one side a cooling system and on the other side a heating system and they don't touch each other. We have a heat generation system on one side and a heat disposal system, and the two are not connected. What can we do today? We can connect them. So on this diagram, what we're saying is, if I have a lot of cooling load, I might still be throwing some of that heat away via the cooling tower on the roof of my building. But I also have the opportunity to reuse as much heat as I can on that heating load. So that unit might then be a heat pump or operating in a heat recovery scenario. And the beauty of that is that you're not just decarbonizing. What you're doing is improving the efficiency of your plant, which what that really means is lower utility costs. So it's all related. You can talk about decarbonization, but we're talking about energy efficiency. We're talking about optimization of energy use. And that means results for your customer, not only in utility bills, but money, in efficiency, and in systems and reduction of carbon. So when we talk about how we do that, often with a water-cooled chiller, we can even look at ways of utilizing heat recovery in 6-pipe systems, saying, well, let's reuse as much heat as we can, and then only throw the rest away. And that can be done individually on an actual unit. So call it a chiller, but call it a chiller being used as a heat pump or a chiller heater. There's lots of different terms, as I said.
So in the summertime, we take heat from inside our house, we put it outside, it cools, and then the gas is cool, and then we pump back into our house, and it brings in cool air, picks up heat, and takes heat outside, and it's a circle. And then in the winter, it just reverses. And the amount of electricity needed to run that, basically a pump that sends refrigerant in this circle, is an order of magnitude less than the energy needed to burn fossil fuels in your basement. So in my basement, I have a furnace, which I put in before I knew what I was doing. And it's like if you look at the flame on it, it is burning 1,000 therms a year. And 1,000 therms a year is 5.4 tons of greenhouse gas every year. And that's what it produces just to heat my house. And a heat pump would do it far less. And soon I'm going to replace it with a heat pump. But what you're finding as when you talk to businesses about introducing this newer technology?
You know, it's interesting. So what we're dealing with right now is that a lot of these cities, for example, will have a decarbonization goal. I want to reduce my carbon emissions by this much by 2030, by 2040, by 2050. But they don't necessarily know exactly how they're going to achieve that. So the questions they're moving to right now are going to their engineering firms and say, I'm going to build this building, or I have an existing building and I need to reduce my carbon footprint. How can I do it? And so they're definitely saying, well, instead of just using a traditional chilled water system and throwing the heat away when I'm doing my air conditioning system, can I reuse that heat somewhere? I'll be more efficient, I'll reduce carbon emissions, and I'll also reduce my utility use. There's also a lot of other impacts, right? Am I using efficient lighting? That's a big one, right? Lighting not only is using a lot of electricity, but it also puts off heat, which creates an additional cooling demand for your chiller. So they're looking at all of those elements, everything that goes into building design today too, right? Where am I building my building? On what side of my building do I have windows that creates additional heat, that changes those heating loads? But yes, absolutely. A lot of places are going, can I replace my boiler and use a heat pump? So I would say that's exactly the question buildings are asking today. How can I reduce my carbon footprint? And should I be utilizing a heat pump in lieu of a gas boiler?
And the gas industry is trying to hold on dearly.
Well, you know, I guess I would say there's a time and a place for everything, right? And there's a strategy that we should employ. And, coming back to the sustainability and the quality elements of it, it doesn't just make sense to employ a heat pump if you're not utilizing your system efficiently. You need to do all of these things, and that includes the quality aspect, and that includes buying equipment that has a low embodied carbon into it, right? We don't want to build huge batteries, but at the same part, impact our environment negatively building the batteries in order to, take these sorts of resources out of our forests and our lakes and in order to build those resources. So it's a balance of everything. It really has to be a balance of everything. But I guess we are at time. What I would say is, on behalf of Trane Technologies, thank you so much for joining us. And if you have additional questions on our products or how to achieve that, reach out to your local sales engineers, and they're going to help you find the right solutions for your buildings.
You've got limited time to do your continuing education. We appreciate you spending the last hour or so with us. So thank you very much. And wherever you're calling in from, good morning, good afternoon, good evening, and enjoy the rest of your day.